Okay, this is the video for 380 to 381. I'm doing 1 through 21 odd, and you're doing 2 through 22 even. Okay, first things first, let's make everything a fraction so that we don't get confused, and we need to find an LCD to get rid of these fractions. Your LCD is going to be the lowest number that all three go into evenly, and in this case is going to be 6. If for some reason you're not sure how to figure out the LCD, take your largest denominator and count by that number. So like 3, 6, 9, 12. And then look at each one starting at the beginning and ask yourself, does each denominator go into it evenly? Does 2 go into 3 evenly? No. So that immediately eliminates that one. Then go to 6. Does 2 go into 6 evenly? Yeah. Does 3 go into 6 evenly? Yeah. Does 1 go into 6 evenly? Yeah. So it's 6. So you don't even have to check the other ones, okay? Now you're going to take that 6 and you're going to multiply it times each piece. And then you're going to divide. 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 1 is just 1, so we're going to leave that alone. Then look at what's left. You have 3 times x minus 2 times x equals 6 times 12. So that's 3x minus 2x equals 72. 3x minus 2x is just x equals 72. And on these problems, you have one additional step after you're done. You have to look at your denominators and make sure they don't have any variables in them. If they have any variables in them, you have to plug this number back in to make sure you don't get no solution. But on this one, we just have numbers in our denominators, so we don't have to plug it back in. So we're good. We know our answer is 72. All right, so let's find our LCD. LCD of 3, 6, and 4. So remember, you're going to count with your largest number. So 6, 12, 18, and let's start with the first one. Does 3 go into 6 evenly? Yeah. Does 6 go into 6 evenly? Yeah. Does 4 go into 6 evenly? No, so it can't be 6. Let's try 12. Does 3 go into 12 evenly? Yes. Does 6 go into 12 evenly? Yes. Does 4 go into 12 evenly? Yes. So it must be 12. You don't even have to check 18. Now you're going to take 12 and you're going to multiply it times each fraction. And then you're going to reduce or cancel or divide, whatever you want to call it. 12 divided by 3 is 4. 12 divided by 6 is 2. And 12 divided by 4 is 3. So you want to look at what you've got left. You've got 4 times x equals 2 times 1 plus 3 times x. So that gives you 4x is equal to 2, because 2 times 1 is 2, plus 3x, because 3 times x is 3x. Subtract 3x from both sides so you can solve. You end up getting x equals 2. Now look at your denominators. Make sure there are no variables in them. There aren't, so we know x equals 2 is our only solution. Okay? Now, find our LCD. Just like we did a couple sections ago when you had variables and variables and constants. We need the 2 represented in our LCD. We need the x represented in our LCD. So our LCD is 2x. And you can go along and check them off. I've got an x, I've got a 2, I've got an x, I'm good. My LCD is 2x. Then you're going to take that 2x and you're going to multiply it times every piece. So this x and this x are going to cancel. This 2 and this 2 are going to cancel. And this x and this x are going to cancel. So let's see what we've got left. 2 times 2 plus x times 1 is equal to 2 times 5. So 2 times 2 is 4 plus 1x, which is just x, is equal to 10. Subtract 4 from both sides. You get x is equal to 6. Now, if I take this 6, because notice on this one, I have variables in my denominator. If I put a 6 in for these x's, will I ever get a 0 in the denominator? No, because it would just be 6 in the denominator. So 6 is an okay answer. So we checked and check, we're good. Something about the blue check mark makes it very official. All right. Let's find our LCD. Our LCD is x. I've got my x covered, I've got my x covered, I'm good, it's just x. Multiply x by each piece. This x and this x cancel, this x and this x cancel, and you're just left with x squared plus 1 is equal to 5. Okay? Should have always put parentheses around this binomial. Subtract 1 from both sides. You get x squared is equal to 4. Square root both sides to get rid of that squared. And remember, anytime you write your own square root, you have to plus or minus your solution. So your answer is plus or minus 2. Now, this problem also has x's in the denominator. So if I put in a 2 or a negative 2 into these x's, would I ever have 0 in my denominator? No, I would have 2 or negative 2. So my answers are good. I can move. All right, first things first, do my parentheses to make me happy. Okay, so in this one, my LCD, you need to get an x plus 3 represented. So this is represented. Need an x plus 3 represented. Well, I already have that, so I'm good. You're going to multiply both sides by x plus 3. These cancel each other. These cancel each other. So you're just left with x plus 5 is equal to 2. Subtract 5 from both sides, and you get x is equal to negative 3. Okay, looking at my denominators, I have a variable there. So if I take my solution and I plug it into the variable, will I get 0 in my denominator? So let's try it, because before it was just x's. That was obvious. So let's look at my denominator. My denominator is x plus 3. If I plug in negative 3 into x, do I get 0? Yes, I do. So therefore, this is not a solution. You cannot have a solution that's going to give you 0 in the denominator. That's undefined. So in this case, the negative 3 is not a solution. So your answer would actually just be no solution, because negative 3 was our only option, and we checked negative 3 doesn't work. So our answer is no solution. Okay, so for number 11, the first thing you need to do is put parentheses around these, and then you're going to need to factor this last one. So you've got x and x, plus and minus, factors of 8 that give you 2 are 4 and 2. So when I go to find my LCD, I'll write it over here since I don't have room over there. I need an x minus 2. I need an x plus 4. I need an x plus 4, but I've already got it. I need an x minus 2, but I've already got it. Okay, so those are my new denominators. So I'm going to multiply each piece by x minus 2 times x plus 4. X minus 2 times x plus 4. X minus 2 times x plus 4. All right, let's see what cancels. Here my x minus 2's cancel. Here my x plus 4's cancel. Here my x minus 2's and my x plus 4's cancel. So let's see what we're left with. We've got a 5 and an x plus 4, a 2 and an x minus 2, and a 4 and a negative. So let's write it out. 5 times x plus 4. Do not skip this step, because if you do, you will inevitably distribute a 2 instead of a negative 2, is equal to negative 4. Okay, let's distribute. 5x plus 20 minus 2x plus 4 is equal to negative 4. Let's combine our like terms. 5x minus 2x is 3x. 20 plus 4 is 24, is equal to negative 4. Subtract 24 from both sides. You get 3x is equal to negative 28. Divide both sides by 3, and you get x is equal to negative 28 over 3. Now let's go back up to the top and see if I put negative 28 over 3 into my denominators, am I going to get 0? So what's going to give me 0 here? 2, right? 2 minus 2 is 0. So 2 is a no-go. What's going to give me 0 here? Negative 4. And those are the same things that are going to give me 0 here. So my only bad solutions would be 2 and negative 4. So let's go and look at our solution down here. It's negative 28 over 3. That is not 2 or 4 or negative 4. Okay? So my answer is okay. All right. So parentheses first. LCD. You need x minus 1. You need an x plus 1. Check, check. We're good. Multiply x minus 1 times x plus 1 times both pieces. Here your x minus 1's cancel. Here your x plus 1's cancel. So let's just write what we've got left. We have 1 times x plus 1 is equal to 2 times x minus 1. So when I distribute a 1, I just still get the x plus 1. When I distribute the 2, I get 2x minus 2. Subtract x from both sides. You get 1 is equal to x minus 2. Add 2 to both sides, and you get x is equal to 3. If I plug 3 in here, 3 minus 1 is 2. 3 plus 1 is 4. I don't get 0. So my answer is just x is equal to 3. You're good there. All right. First things first, you need to factor. So this denominator's fine, this denominator's fine, but I need to factor this one. So I've got 2x and 2x minus plus factors of 6 that give me 5. My favorite could be 3 and 2, could be 6 and 1. I'm going to go 6 and 1 because I need a negative 5. All right, this house has a 2 in common, so I end up with x minus 3 times 2x plus 1. Now let's FOIL to make sure that works out, or double distribute. 2x squared plus 1 minus 6 minus 3. Yep, we're good. So we can cross these out. This is my new denominator. So I need my LCD. I need an x minus 3, and I need a 2x plus 1. X minus 3, 2x plus 1, x minus 3, 2x plus 1. You're going to multiply that times every piece. So I have x minus 3, 2x plus 1, x minus 3, 2x plus 1, x minus 3, 2x plus 1. Here my x minus 3's cancel, and my 2x plus 1's cancel. Here my x minus 3's cancel, and here my 2x plus 1's cancel. So let's talk about what we've got left. We've got x squared minus 23 plus 2 times 2x plus 1 is equal to negative 1 times x minus 3. Distribute the 2. You get x squared minus 23 plus 4x plus 2. Distribute your negative 1 equals negative x plus 3. Okay? Negative 23 plus 2 can be combined, but first I'm going to write them in order. So I'm going to go x squared plus 4x. Negative 23 plus 2 is negative 21, is equal to negative x plus 3. So I'm going to add x to both sides, and you'll get x squared plus 5x minus 21 is equal to 3. Subtract 3 from both sides. You get x squared plus 5x minus 24 equals 0. And remember, the reason that I made this equal 0 is in order to be able to solve this, I'm going to have to factor. So each one gets an x, plus, minus, factors of 24 that give me 5. Let's see, 24 and 1, 12 and 2, 3 and 8, 6 and 4. It's going to be 3 and 8. Okay? So then you do x plus 8 equals 0, and x minus 3 equals 0. So here you're going to subtract 8 from both sides. So you get x equals negative 8. Here you're going to add 3 to both sides. You get x equals 3. So let's go back up to the top and see if 3 and negative 8 are good answers. So let's see. I've got, if I put a 3 in here, won't that give me 0? 3 minus 3. So let's, oh, what did I just do? There we go. So let's scroll back up here. We know 3 won't work because 3 is going to give me a 0. All right, let's see what else. 2x plus 1. If I put a 3 in there, I get 6, 7. If I put an 8 in there, okay, so 8's okay. So my only solution will be 8 is negative 1, or x is negative 1. Oh my gosh, x is negative 8. Holy crap. Okay, so you notice you have to check, because on this one of them worked and one of them didn't. Only negative 8 is one of your solutions. Okay, first things first, put parentheses around your binomials. Notice, what is this? Shocker. Difference of squares, guys. It's going to keep coming up. I wasn't kidding. So when you go to write your LCD, you want an x minus 4, and you want an x plus 4. That covers here, 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 and here. So you multiply each piece by x plus 4 times x minus 4. X plus 4 times x minus 4. X plus 4 times x minus 4. Then you see what cancels. Here it's the x minus 4s, here it's both, and then here it's the x plus 4s. Now write what you've got left. You have 1 times x plus 4 minus 3x equals 2 times x minus 4. Distribute. X plus 4 minus 3x is equal to 2x minus 8. Combine like terms. X minus 3x is negative 2x plus 4 is equal to 2x minus 8. I'm going to add 2x to both sides to keep my x positive, leaving me 4 is equal to 4x minus 8. Add 8 to both sides. You get 12 is equal to 4x. Divide both sides by 4, and you get x is equal to 3. Now go back up here and see if 3 is okay. 3 minus 4 is negative 1, so we're good there. 3 plus 4 is 7, and we already checked those, so 3 is an okay answer. So you go back down and say, yep, we are good. Check for 3. Oh my goodness, difference of squares again. So we have x minus 4, and then this changes to x plus 4 times x minus 4. So your LCD is going to be x plus 4 times x minus 4. And that's what gets multiplied by each piece. Here the x minus 4s will cancel. Here both cancel. So you're left with 1 times x plus 4 equals 8. If you distribute a 1, you still just get x plus 4. Subtract 4 from both sides, and you get x is equal to 4. If I put 4 in here, am I going to get 0? Yes, 4 minus 4 is 0. So this is not a good answer. So your answer is no solution. So see what happens if you don't check. You would say the answer is 4, and the answer is no solution. And I guarantee you 4 is going to be an option on the test. So please. All right. Last one. Put parentheses here. Here you're going to factor out an x, leaving you x minus 2. And here you need to put this over 1. So your LCD is x times x minus 2. Because you need the x minus 2. You also need the x. You need the x minus 2. You need the 1, but 1 times that is just the same thing. So you're going to do x times x minus 2, x times x minus 2, and x times x minus 2. These x minus 2's cancel. These x's cancel, and these x minus 2's cancel, and nothing cancels in the last one. So what do we have left? We have 1 times x, which is just x, minus 2 equals x times x minus 2. So we're going to distribute our x. So we have x minus 2 is equal to x squared minus 2x. And we need to get everything equal to 0, because if we have an x squared, you know you're going to have to factor to solve this. So, well, I should say if you have an x squared and an x, you know you're going to have to factor. So let's subtract x from both sides, giving me negative 2 is equal to x squared minus 3x. Then add 2 to both sides. So you get 0 is equal to x squared minus 3x plus 2. Then we're going to factor. So if I factor this, factors, so it's x and x, minus minus, factors of 2 that give me 3 are 2 and 1. And remember, this is still equal to 0. So then you do x minus 2 is equal to 0, and x minus 1 is equal to 0. Add 2, you get x is 2. Add 1, you get x is 1. So let's check 1 and 2 and see if they're okay. If I put a 1 in here, 1 minus 2, I'm okay. If I put a 1 in here, it would be 1 times 1 minus 2, so I'm okay. 1 is good. Let's try 2. Uh-oh. 2 minus 2, that's a no-no, so 2 won't work. So your only solution is x equals 1, and we checked that one, so we're good. Okay? And that's it. You guys have a good night, and I will see you tomorrow.